Doing this stuff is the distance formula, d equals r times t. D equals r times t. But even with the kinds of problems we're doing today, we're going to be using substitution and elimination to solve them. Nice word. We're going to be doing substitution and elimination to solve these problems. So really, this isn't going to be too hard. It's not, I promise.
You always say it's not going to be hard.
Well, pay attention then.
And then I bash my head into the wall.
Distance equals rate times time. Distance equals rate times time. And to do these equations, yes, sir?
It was negative 5 times 2. It's -10.
Negative 10. To do these problems, we are going to create two different kinds of graphs to illustrate what we're doing. So here are my two graphs. What? There's no graphs there. There is. Okay, so these problems come because we're talking about two different variables that are going to be in our problems. And one is going to take this shape. Distance 1 is going, and distance 2 is going. And it'll take this shape. So sometimes you're probably going to say graph it out first, just so you know what's happening in the problem. Okay, so they're both going in the same direction. Okay? And the other one, you have one going one way and one going the opposite direction. So this is a graph just to kind of help you figure out what is happening here. All right, so you're going to get a shape just like this. And this will help you to solve these problems. These problems are just using substitution and elimination like we've been doing. And all you need to do is read carefully what you're being told in the problem to be able to solve it. All right, so here we go. Deep breath. Here we go. You read the equation first, and you can tell me which graph that was, the first one or the second one. On Tuesday, the express trains made the trip in 12 hours. I just told you the express trains made the trip in 12 hours. On Wednesday, the freight train made the same trip in 16 hours. Find the rate of each train. Did they go to the same destination? All right, so which graph is it? Okay, so we have two kinds of trains. We have the express and we have the freight. So here's our graph. The distance of the express is the same as the distance of the freight train, correct? They went the same destination from the same place. What was the difference? Well, here's the difference. Find the rate of each train if the rate of the freight train was 15 kilometers per hour less than the rate of the express train. Okay? But what this graph is telling us is the distance of the express train equals the distance of the freight train. They went the same exact distance. Our word problem specified that. All right, now remember that formula, D equals R times T? Remember that formula? We're going to also use that formula to help us solve this problem. Well, the distance of the express train equals the rate of the express train times the time of the express train, right? And the distance of the freight train equals the rate of the freight train times the time of the freight train. All we did was for D equals R times T, I subscripted it to show the difference between express and freight, right? That should not look confusing because all I did was just make it clear which one's which. All right? Now let's substitute what we can do. All right, here's our first substitution. Remember here? See this right here? What I started with this graph? D of the express, the distance of the express equals the distance of the freight. What's over here? Distance equals rate times time. So let's substitute that information. Rate of the express times the time of the express equals the rate of the freight times the time of the freight.
This is just like,
Are you with me so
Yeah.
far, what I just did?
yeah.
Okay, all I did was for D, I substituted that. Okay? All the problems that you're gonna do are gonna, or at least half of the ones you're gonna do are gonna take this form. We'll do the other one in a minute. Okay, now we do know, as of right now, I have given you more information, but right now we still can't solve it. We have to plug in the rest of the information. It tells us the time the express took was what? So the time of the express equals 12. And the time of the freight equals 16. Okay, so now we have some stuff to plug in. And we also know the rate of the freight train. The rate of the express equals the rate of the freight plus 15. We know that, right? So you said that the freight train was 15 slower. Do I have enough information to plug stuff in now? All right. I have all that I need to solve this problem. So if I plug everything in, I can totally solve this. I get 12 times RF plus 15 equals RF times 16. I didn't have to put parentheses there, but I did. That was my thinking. I got enough to solve it. So that's 12 RF plus, what's 12 times 15? So
180.
180 equals 16 RF. I got enough to solve it now, don't I?
Yeah.
Subtract 12 RF on both sides. What do you get? You get 180 equals 4 RF, correct? Right? And then if I divide by 4, what's 180 divided by 4? What?
45.
45. So the freight train was going 45 kilometers an hour. Because freight, you have, it's kilometers per hour, miles per hour, whatever. That means the express train was going 60 kilometers per hour. Right? This isn't too hard when you think about it.
It just looks slow.
There's a lot to it because this is where we're starting from. But what did we do? We plugged in the information we knew. It's just, the trick for us is this stuff here. And that's what we're going to do with the next problem. Now the next kind of problem, also, I'll give you the graph now, is this one. D1 and D2. Are they both traveling the same distance in that graph? Are they? They're going opposite
Oh, yeah.
directions, but are they
Yeah.
traveling the same distance?
Oh, they're getting.
So distance of one equals the distance of the other, just like in the problem before. Okay? So if the members of the girls' club hike to Lake Tenkiller,
10 killer?
it's in the book,
They go with the
at 2 miles per hour, Mr. Ali gave them a ride back home at 12 miles per hour, bumpy road. Find their hiking time if it was 5 hours longer than their riding time. So they went, they hiked one way and they rode back, that's an R, the other way. Okay? Did they travel the same distance? Sure they did. The problem tells us that. Distance they hiked equals the distance they rode. Okay? Which means I can also translate to their rate they hiked times the time they hiked equals the rate they rode times the time they rode. Right? Distance formula, D equals R times T. I can translate that because RT does equal D. Do you understand that concept here? If you don't, then you're going to get lost. If you do, you're good. They said they hiked, or they did 2 miles an hour. Their rate was 2 miles an hour. So RH was 2. RD was, or the R, their rate for riding was 12, correct? And it says that their hiking time was 5 hours longer than their riding time. All right, so that also tells us the time they hiked equals the time they rode plus 5. Got enough information to solve it now?
Yeah.
You bet you do. All right, so you got 2 times TR plus 5 equals 12 TR. So 2TR plus 10 equals 12 TR. Subtract 2 TR on both sides. Okay, what do you end up with?
10 equals 10 TR.
That's TR equals 1.
Okay? So what do you end up with?
TR equals 1.
Okay. 1 and 6, right?
Yeah.
Very good. Okay. The time they hiked was what? The time they hiked was 6. The time they rode was 1 hour. Okay? What do you think? Think that's too hard?
No.
And then you get 64 pancakes.
You did get 64 pancakes, so I think you can get it.
It's just like that one thing that I don't know how to explain it. It's like
If you need to memorize anything, it's this. Okay?
Are they all gonna
like
For today, yes.
like this part.
Later, they might be a little bit, there's some different stuff, but that's a different thing to memorize. For today, all you need to memorize is, if their distances are the same, we can translate their rates and time for distance.
Yeah.
That's it. If you can memorize that part, the rest is easy because all you do is plug in. You've learned how to plug it in.
Yeah. There's.
This is the only new thing right here. The cloud is the only new thing that we
we're
did
just
today.
making the initial equation and then we're plugging things.
Right. It tells you
Instead of
everything to
just
plug
plugging
in.
things
You know how to plug the stuff in. All that you need to know is this part right here. This is the new thing. That's it. That's the only new thing here. The only thing that might trip you up is this part. But you do know how to solve. Long time ago, you learned how to build equations from words. That's all you're doing. Because if the time they hiked equals the time they rode plus 5, because that said that was 5 hours longer, that's fairly easy to translate. That's the only other, that's not new. The only new thing is the cloud that I drew. Okay? Cool? Cool.